Okay, welcome to the first session of chemistry today. Yesterday, I was dealing with the properties of, Mansi, good evening, the properties of aldehydes and ketones. I gave you the addition reactions, addition elimination reactions, and some special properties to discuss. I am going to give you some more properties of aldehydes and ketones, and if there is an exception, I am going to explain that also. Radhika, hello. We start with the question of previous class. Acetic acid is reduced by lithium aluminium hydride to give A. A is passed over copper and heated to get B. B is treated with sodium hydroxide to give C. C is heated to give D. What is D? Acetic acid with lithium hydride, you already know, acid is reduced to primary alcohol. Primary alcohol, if you pass it, the vapors of it, if you pass it through copper at 573 Kelvin, it results in the form dehydrogenation takes place, giving ethanol. Ethanol with NaOH undergoes Aldol condensation to give CH3, CH white, CH2, CHO, 3-hydroxybutanol. This one is 3-hydroxybutanol. This on heating undergoes dehydration, OH from here, H from here, excuse me, gives rise to crotonaldehyde or but-2-enal. Therefore, the answer is D. The answer is D, crotonaldehyde, or it is called but-2-enal. Okay, right. We shall pass on to, so what I said in the previous class, properties of aldehydes and then properties of ketones. Special properties of aldehydes and ketones are to be studied. That means some reactions having names. What are those reactions? You already know this. This is haloform reaction, which I have already explained. The reducing agents, lithium aluminum hydride, sodium borohydride and hydrogen in presence of nickel, how they act on which part of the aldehyde? Yes, I have explained. This also again the part of the previous one, yes, explained. Selenium dioxide oxidation, alpha hydrogen atom, CH3 having alpha hydrogen atom undergoes oxidation, explained. This is called Pinacol Pinnacolone rearrangement. It is a special reaction. Pinacol Pinacolone rearrangement. Now, hello Akshay. Yes, good evening. First you said Akshay, hi guys, that's for your friends, not for me. Then you said hello sir, and you said good evening. Now I am answering good evening Akshay, Mansi, etc. Yes, acetone or propanone, two molecules. If you heat it with magnesium or with mercury, same reaction, in benzene as the solvent, it results in the formation of the magnesium compound like this, that undergoes hydrolysis. So, H and H, you will get OH and OH, MgOH twice will come out and you get this diol. This diol undergoes dehydration, When it undergoes dehydration, it undergoes some change also, the rearrangement will take place. What is that rearrangement? H2O will be removed. Yes, Pratap Singh, yes, good evening. Dehydration takes place and then this CH3 will be transferred here and O will be transferred there. You get CH3, 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 CO, CH3. So, Pinacol, an alcohol, is converted into ketone, and during this there will be exchange of keto group with methyl group. This is called pinacolone. Since it is a ketone, it is called pinacolone. This reaction is called Pinacol-Pinacolone rearrangement. Yes, Sohan Rastagi has given, yes, shifting of the reaction takes place because the tertiary butyl carbon atom is more stable, hence it forms this compound CO. The IUPAC name of this compound is 1, 2, 3, 4, 3,3-dimethyl butanone, 3,3-dimethyl butanone. This is called Pinacol-Pinacolone rearrangement. This is called Pinacol, this is called Pinacolone. So, acetone undergoes this particular reaction. Okay. The next one, again this is a reduction reaction. Before I go to this, I will explain one more reaction and then come to that. This is the reaction which I want to explain, then I will come to that. Yes, or amalgams here, like magnesium amalgam are soluble in every organic solvents. Magnesium amalgam, no, see amalgam, Akshay, we do not speak anything about amalgams, solubility, etc. Amalgam will reduce the reducing power of a metal. Activity of the metal is reduced. Sodium amalgam plus ethyl alcohol. With sodium and ethyl alcohol, the reaction is so fast nascent hydrogen is given, immediately all nascent hydrogen, there will be wastage of hydrogen and the reaction will not complete. There should be slow release of hydrogen, nascent hydrogen, and that must be utilized. See, for example, Akshay, you are hearing me? You take RCl, you treat this with zinc amalgam and or sodium amalgam, and ethyl alcohol. So, 2H will be utilized, you get RH plus HCl, RH plus HCl, okay. So, I will come to that. So, here if you use RCl with sodium and ethyl alcohol, small quantity of RCl becomes RH, that is all. The rest of the reaction will not take place at all, whereas here slow release of hydrogen and all RCl can be converted into RH. This will reduce the activity of sodium metal. Sodium is a very good reducing agent like lithium, good reducing agent. So, sodium plus water, vigorous reaction liberating hydrogen. Sodium plus ethanol, vigorous reaction liberating hydrogen. Therefore, you have to reduce the activity, hence sodium amalgam is used for this. Zinc amalgam, sodium amalgam, etc. are used for that particular purpose. Okay, right. Coming back to our explanation, the reduction process of aldehydes and ketones, this reduction you already know is called Clemmensen reduction. Clemensen reduction. If you reduce an aldehyde or a ketone by zinc amalgam and concentrated HCl, zinc amalgam and concentrated HCl, which releases nascent hydrogen, CO group, whether it is present in aldehyde or present in ketone, gets reduced to CH2 group. So, Clemensen reduction reduces CO group into CH2 group. Thus, ethanal or acetaldehyde forms ethane and then acetone or propanone becomes propane. CO group is reduced to CH2 group. So, what is bathochromic shift? Is it related to colors of group 17? See, Radhika, again diversion from what I am explaining. Okay, since you have explained. So, Clemensen reduction is this. I will go to the next reduction, similar type of reduction here, and I will come to that. I will write the name of this. This is Wolff-Kishner reduction, WOLFF, Wolff-Kishner reduction, Wolff-Kishner reduction. I will explain this, Radhika, I will come to that, because Clemensen reduction and Wolff-Kishner reduction are similar. Reducing agents are different. So, I will explain this and explain your question. So, acetaldehyde is finally converted into CH3, same as Clemensen reduction. Acetone is converted into propane, same Clemensen reduction. For this, aldehyde reacts with hydrazine to to form hydrazone. This is acetaldehyde hydrazone. If you heat it with glycol in the basic medium or in an alkaline medium, it gets reduced to CH3 plus NH3, not NH2, ammonia is obtained. So, plus H2O is obtained. This is Clemensen, this one is Wolff-Kishner reduction. Same, it has been given in one step, actually it is a 2-step or 3-step reaction, it gives propanone. You may ask me the question, what is the speciality of Wolff-Kishner reduction when we have simple reaction like zinc amalgam and concentrated HCl? The reason is, the speciality of this is, suppose you have a reaction like this. If you have like this, if you use Clemensen reduction, this will also be reduced. So, I repeat, suppose you have CH3, CH, double bond CH, CH2, okay, COCH3, COCH3. If you use might severely reduce, certainly, usually amalgams are used. See, it is an alloy. Amalgam is considered to be an alloy. Reduce the activity of the metal and controlled release of usually hydrogen reduction. Okay. If you do it by Clemensen reduction, there is possibility for this compound to be formed, CH2, CH2, CH3. Whereas, if you do it by Wolff-Kishner reduction, you get CH3, CH, double bond CH, CH2, CH2, CH3. Specific, it will reduce CO into CH2. This is the advantage of Wolff-Kishner reduction when compared to Clemensen reduction. Products are same, reduction is same, reagents are different, and the purpose of using two different reactions, Wolff-Kishner and Clemensen. Okay. Now, I will come to the question asked by Radhika. This is benzene. Yes, thank you, Akshay. This is benzene. Benzene is colorless because it cannot absorb light in the visible region of the spectra. Now, so it absorbs light, let us say, in the UV region. You heat it with nitric acid, sulfuric acid mixture, you get nitrobenzene. Nitrobenzene is yellow in color. That means it absorbs light in the visible region of the spectra. Visible region of the spectra. That means wavelength has increased. Absorption band wavelength has increased. This shift I think Radhika you are hearing me. This shift from UV to the visible, from lower wavelength to higher wavelength is called bathochromic shift. Bathochromic shift. The reverse is called hypsochromic shift. Reverse. From longer wavelength to lower wavelength. Okay. So, I will continue with you some more details. Nitrobenzene is yellow in color, but it is not a dye. This NO2 group which gives color to the compound is called a chromophore. Chromophore. So, if a compound contains a chromophore, then it is a colored compound, but it need not be a dye. It is nitrobenzene is yellow. If you introduce one more nitro, it becomes darker yellow, etc. If it is to be a dye, then the compound should have a salt forming group like OH, NH2, etc. acidic or basic groups, then it becomes a dye. That is why you have picric acid, colored compound. Picric acid is colored, which can be used as a dye, but not a very fast dye. This OH group or NH2 group, the salt forming group is called oxochrome. Oxochrome. So, if a compound is to be colored, chromophore is sufficient. If a compound is to be a dye, we need chromophore and an oxochrome. Chromophore is one which bears, which gives color. Oxochrome is one which is salt forming. Okay, right. Then after that, so we shall come to another special reaction. This is an oxime. An oxime is converted into a derivative of amide. So, this compound is CH3 CO NH2 is acetamide. This compound is CH3 CO NH CH3. This is N-methyl acetamide. N-methyl acetamide. So, acetamide changes to N-methyl acetamide. So, this changeover is a very special reaction which is carried out by concentrated sulfuric acid or thionyl chloride in ether. So, this is oxime, and you know that oximes are obtained when an aldehyde or a ketone reacts with hydroxylamine. Hydroxylamine. So, when this is treated, it forms N-methyl acetamide with sulfuric acid. It forms N-methyl acetamide. That means there is shift, just like Pinacol, Pinacalone rearrangement, there is shift in the CH3 and oxygen, similar to that Pinacalone rearrangement. CH3 and O are exchange their position. So, it results in the formation of a derivative, alkyl derivative of amide. So, this is N-methyl acetamide, whereas this one is N-phenyl benzamide. Why is it called N? because phenyl group or methyl group is connected to nitrogen atom. Okay, oxime to that. Then the next one, another important reaction of aldehyde, aldol condensation. You know this? Aldol condensation. CH3 CHO, CH3 CH2 CHO. In the old system or the common system, functional group next to the carbon atom next to the functional group is called alpha carbon atom. So, this is alpha carbon atom, this is alpha carbon atom. If the alpha carbon atom carries hydrogen, I repeat, yes, I repeat, if the alpha carbon atom has got hydrogen atom, this will undergo a special reaction called aldol condensation. Aldol condensation. How exactly the reaction takes place? It is actually nucleophilic addition first, nucleophilic addition, later electrophilic addition, and then dehydration takes place. We shall see the reaction, different types of reactions. So, aldol condensation, CH3 CHO plus H CH2 CHO in presence of a base like sodium hydroxide. I have already told you under Radhika, Mansi, Akshay, etc. I have already told you under addition reactions, if hydrogen is available, hydrogen adds on to oxygen, remaining group adds on to carbon. So, this is minus, this is plus, this is plus, this is minus. Therefore, you get the addition compound CH3, CHOH and then CH2 CHO, CH3 CHOH CH2 CHO. This is how the reaction takes place. If you heat this compound further, it undergoes dehydration like this, OH from here and H from here gives rise to CH3, CH, double bond CH, CHO, double bond. So, you get crotonaldehyde. This can be called, that is why it is called condensation reaction. Usually condensation reaction is one, A plus B giving rise to C is addition reaction. A plus B giving rise to C plus simple molecules like water, HCl, etc. is called condensation reaction. So, two molecules of acetaldehyde combine and later dehydration takes place, giving, first you get aldol. An aldol is a compound containing CHO group and OH group. Later it forms alpha beta unsaturated aldehyde. This is aldol condensation. Okay, right. Now, the same has been given here, the second part of it, heat, H2O is removed, you get CH3CH. Unfortunately, HashLearn has stopped. Yes, so this is. Now, I would like to explain crossed Aldol condensation. If 10% NaOH is used, sir, Akshay, the reaction takes place with dilute NaOH. See here, the actual reaction is like this. NaOH gives rise to Na plus plus OH minus. Radhika, what's your, does Aldol condensation is done in presence of barium hydroxide also? It can be done, but Radhika, the thing is, it should be very dilute. Barium hydroxide, just like sodium hydroxide, is a very strong base. It should be a very dilute one. If it is a dilute one, Na plus and OH minus, you have the nucleophile OH minus. OH minus plus CH2 CHO. This will come over here and this will come over here. You get H2O and CH2 CHO nucleophile. That is why I said nucleophilic attack. CH3CHO with a nucleophilic attack. Did you follow, Akshay? Dilute NaOH undergoes, you know that a strong electron, if it is, the dilution will increase the ionization, degree of ionization. So, dilute is to be used here. Okay. Then coming to crossed Aldol condensation, crossed one. Suppose you have C6H5CHO plus C6H5CHO, sorry, CH3CHO I realign CH2CHO in presence of dilute NaOH, H2O will be, this is all Aldol condensation. This is the reaction is just this. If you avoid the intermediate step, it gives cinnamaldehyde or 1, 2, 3, 3-phenyl proptoenal. This is called Claisen condensation. Claisen condensation. Claisen condensation. So, this is crossed aldol, but the thing is, out of the two compounds, one should contain alpha hydrogen atom. Benzaldehyde plus benzaldehyde, no reaction, that will give rise to Canizaros reaction. Okay, right. Now, coming to another important reaction, Canizaros reaction. Canizaros reaction. Canizaros reaction is also called disproportionation reaction. Disproportionation. Disproportionation reaction. This will take place where the aldehyde has no alpha hydrogen atom or no alpha carbon atom. No alpha carbon atom. Claisen condensation keto ester is formed, not ester, that is different. Claisen ester condensation. Claisen ester condensation is different from this. This is just Claisen. This is Claisen Schmidt reaction is there. Claisen ester condensation is there. Claisen ester condensation comes under acetoacetic ester, preparation of acetoacetic ester. So, acetoacetic ester is CH3, CO, CH2, COO, C2H5. There you come across that ester condensation. I am speaking of the aldehyde crossed aldol condensation. So, this is Canizaro's reaction. There should be no alpha hydrogen atom. If there is no alpha carbon atom, well and good. Sir, in Claisen condensation, yes, beta keto ester. Now, formaldehyde, you know that an aldehyde on oxidation gives a carboxylic acid, an aldehyde on reduction gives an alcohol. If you treat it with a strong solution of NaOH or even KOH, one molecule of aldehyde undergoes oxidation, one molecule undergoes reduction. So, if alpha hydrogen is absent in aldehyde, Canizaro's reaction or auto oxidation reduction takes place. NaOH is neither an oxidizing agent nor a reducing agent, but in presence of sodium hydroxide, formaldehyde, benzaldehyde undergoes self oxidation reduction. That is why it is called auto oxidation reduction reaction. We are not using any reducing agent. Still, formaldehyde undergoes oxidation to formic acid. Formic acid with sodium hydroxide will give sodium formate and methanol, reduction methanol. Similarly, benzaldehyde on reduction gives benzyl alcohol, on oxidation benzoic acid with sodium hydroxide will give sodium benzoate. So, this auto oxidation reduction reaction is called Canizaro's reaction. Suppose just like crossed Aldol condensation, if you have crossed Canizaro's reaction, C6H5CHO plus HCHO in presence of sodium hydroxide. Remember, the smaller and simpler aldehyde undergoes oxidation. So, you get C6H5CH2OH plus HCOONA. The smaller molecule aldehyde undergoes oxidation, the bigger one, the bulkier one undergoes reduction. Okay? Right. That is about Canizaro's reaction. Next one is Tollens reagent test. This is answered only by aldehydes, and this reaction is used in silvering mirror or silvering a glass and converting it into mirror. Sir, please can you explain auto oxidation once again? Yes, Akshay. See, CH3 CHO with lithium aluminum hydride becomes CH3. Akshay, neither oxidizing nor reducing, then what is its role? Yes, CH3, yes, CH2OH. Again, Akshay, here we are using a reducing agent to get an alcohol. CH3 CHO on oxidation by KMnO4 gives CH3 COOH. Did you follow? So, you need a reducing agent, you need an oxidizing agent, but here we are not using any oxidizing or reducing agent. In presence of sodium hydroxide, which gives the nucleophile OH minus, the reaction is initiated first. One molecule undergoes oxidation and one molecule undergoes reduction. If you see the mechanism, you will see how exactly this oxidation reduction takes place. Auto, self, in presence of sodium hydroxide, one molecule of formaldehyde undergoes oxidation, one molecule undergoes reduction. We are not using any such auto, that is why it is called auto oxidation reduction. So, this is, if you study the mechanism of this, you will know how exactly the oxidation and reduction will take place. You can get into the details, the mechanism of the reaction in the book. You please go through that. Okay. In silvering mirror, Tollens reagent. So, Tollens reagent is prepared like this. Its time up another 4 minutes. AgNO3, we have to go to the context question also. AgNO3 plus NaOH will give brown precipitate of Ag2O. This Ag2O, if you dissolve in drop by drop ammonium hydroxide, that is called ammonical silver nitrate solution. Yes, yes, you have to, how exactly this oxidation reduction takes place, you have to see the mechanism. Yes. So, Ag2O with ammonium hydroxide is called ammonical silver nitrate, and it will have the complex AgNH3 twice OH minus or AgNH3 twice plus. If you heat this with an aldehyde or CHO plus AgNH3 twice OH, it results in the formation, actually it behaves like Ag2O. So, it forms RCOOH plus 2Ag. So, Tollens reagent is a mild oxidizing agent. It oxidizes aldehyde to carboxylic acid, and silver oxide will be reduced to silver. You get silver mirror. This test is called silver mirror test. Wonderful test. As I said earlier, it is used for silvering mirrors. You please, when you go home today, you please see the back of the mirror, at least the broken mirror. What are the colors you see? You see orange, you see green, you see grey. Why they are different colors? What may be the reason? Okay, right. The next one is Fehling solution. Fehling solution is copper sulphate plus sodium hydroxide plus Rochelle salt. Rochelle salt is sodium potassium tartrate. Sodium potassium tartrate, that is COONA, CHOH twice, COOK. This is sodium potassium tartrate. If you actually, Fehling solution is mixture of Fehling solution A and B. Those two must be mixed only at the time of the reaction. Fehling solution A is copper sulphate solution. Fehling solution B is Rochelle salt plus sodium hydroxide. If you mix it and add aldehyde and heat it, it results in the formation. Copper sulphate contains Cu2 plus, it gets reduced to Cu plus, and that Cu plus will be cuprous oxide. So, aldehydes reduce Cu2 plus into C, or aldehydes, simple reaction, RCHO plus or CHO plus 2 CuO gives rise to red precipitate of cuprous oxide and RCOOH. This is the crux of the problem or the reaction. So, this is Cu2O. So, these are some of the function of copper sulphate is to form a complex which is soluble in water. So, these are some of the special reactions which I wanted to discuss. Now, previous class contest question. The answer is D. Benzene undergoes Goterman-Koch reaction with carbon monoxide and this, it gives benzaldehyde. Benzaldehyde undergoes aldol condensation with CH3CHO and then undergoes dehydration to form this, that is CHO. Yes, I will come to that. When heated with Tollens reagent forms an acid. Tollens reagent is an oxidizing agent, just now I said it undergoes decarboxylation to give this compound. This is styrene. Who has answered this question? D is styrene. I don't know who has answered the question. Yes, answer D. Winner Mansi. Congratulations. An atom session will be added to your account. Today's question: 1122 tetrabromopropane is heated with zinc dust to get A with Hg2 plus and dilute sulfuric acid at 333 Kelvin gives B. The compound undergoes tautomeric chain. So you get C. After tautomeric chain, you get C. C with moist bleaching powder. If you heat it, it gives D and E. What are D and E? Okay, so this is the contest question. With this, I have completed the special properties which I wanted to mention of aldehydes and ketones. Thank you very much. Now you have get the passport question, get access to the class practice packs sent by me. Thank you very much.